Today we're talking about buoyancy, right? And so the buoyancy is when you take something and you put it into water, you put it into air or something like that, and then the environment, the substance you put it in, supports it. So when you jump into a pool, you're held up by the water somewhat. A hot air balloon is held up by the air around it, okay? So I have this piece of metal. It has about 5.5 newtons that it's being pulled down by gravity. And then if I lower it into the water here, the water is going to hold it up. It's going to support it a little bit. And there's a cool rule we can find out, and that is however much water this displaces, that's how much it's, that weight of that water will be how much less this is going to be pulled down. So here we're going to slowly lower it down into the water, and you'll see that some water runs out of the jar. There we go. All right, it's totally in the water there. All right, and we just displaced some water. Okay, so now instead of 5.5, we are at about 4.5 newtons. Okay, so we've lost about 1 newton's worth of force on the piece of metal. Okay, well, where did it go? Well, it's down here in this water here. Like this water should weigh about 1 newton. So if I put it back up into this part here, we're back at 5.5 newtons again. Okay? So the amount of water that this piece of metal displaced is the exact amount that that piece of metal is supported. So in the episode where we found out how dense I was, right, we know that I have a volume of about 69 liters. So when I jump in a swimming pool, I displace 69 liters of water, okay? And the mass of that water, that's how much of a buoyant force I have on me when I'm in the water. So I'm held up. So I would feel, if I put myself on a scale in a swimming pool, I would have that much less force registered by the scale. My mass stays the same, but that's a whole nother argument. All right? So what we have here is a tube of water with a cork floating on each end. Right? And the water is supporting the corks, right? Because the corks displace the water, and so they have a buoyant force underneath them. They're floating up here. And if you remember about circular motion, right? When we make this go in a circle, we're going to have a centripetal force pulling things to the middle, all right? And that's going to basically mean that the water weight will be kind of pulled to the outside as these things supporting, and the corks are going to float in towards the middle. Circular motion going on here combined with buoyant force. So get this thing spinning, there we go, and they meet in the middle. They're floating at the middle due to the centripetal force pulling the water the other way, and then they float back again. Voila, beautiful. Now if you bring balloons home, helium-filled balloons home, for someone's birthday party in the car, and you hit the brakes really fast, what happens? Well, when you hit the brakes really fast in the car, you kind of pull forward because you got momentum saying you're going to slide forward. But if you watch balloons carefully, they actually go the other way. All right, here I've got an air-filled balloon and a helium-filled balloon in a little glass box, keep the air from moving. And so if I pull it this way really fast, right, the inertia says that they should stay still, right, and so they should end up fading back towards the back of the box, right? So I'm going to pull it real fast. Here we go. 1, 2, 3. Okay. So when I pulled it really fast, you saw that the top one swung back a little bit, and the bottom one swung forward. Let's try that again. Okay, not when I was done, but when I was first pulling it. What's going on here? Well, the key thing to remember is that not only are there balloons in this box, but there's air. Okay, when I pull the cart really hard, the air actually gets squished towards the back of the box. All right? And so since there's more air in the back of the box than the front, right, then the helium-filled balloon gets pushed and gets supported forward. Actually a buoyant force again. Where the top one is filled with air, right, it gets pulled back along with the regular air, and so it's pulled back. So there you go. So next time you're taking balloons home from the store, if you have convinced your parents to hit the brakes real hard, you can watch the helium balloons float backwards in the car. Whoosh! Episodes ago. Circular motion says that you need a centripetal force to get it to go in a circle. So when I start this moving in a circle, the weight of the water will be pushed to the outside, and these corks will float to the middle. So it's pretty cool. Here we go. Get it spinning nice and fast, and all right, let's try that again. This one is stuck. Yeah, it's spinning fast. There we go. And there we have the two corks. They're floating in the middle. And then if I slow it down, we can bang them back out. There we go. Come on. Never mind. We'll just use that. There we go. We get them in the middle. Right there. All right. Let's try that whole thing all over again, too.